circle book. Remember, you can use this for tests and quizzes. So you want to have this information down. A central angle. Central angle goes through the center. B is the center, so it has to be included. So a central angle would be ABC. Okay? The central angle does equal the arc. Arcs are on the outside. So AC is equal to angle ABC. Whatever degrees they are, they're the same. Minor arcs are less than 180. Major arcs are greater than 180. And 180-degree arcs are called semicircles. 180-degree arcs are called semicircles. Okay, please make sure you have all of this down in your circle book.
What does that say, the one you circled, like after the equal?
This?
No, the one you circled.
This?
Yeah, like after the equal, what does it say? To the right.
Measure of arc AC.
So it's MAC?
Yep. Shh. Guys. When you're done, please have the notes. The notes start with central angles and arcs at the top, then circumference of a circle. We're going to look through those. Okay, just a minute or two, guys. Yep, for today. We're going to add more stuff about inscribed angles tomorrow.
So,
All right. Central angles and arcs notes. Guys, you need to stop talking. That's the third time I've asked you to do that. Okay. Circumference of a circle we know is 2 pi r or diameter times pi. Okay. Central angle goes through the center. Justin, will you put the door closed so I can't hear other people? Okay, this little equation right here we'll use more when we talk about sectors. We're going to use some of it today to do these notes. And I'm just introducing it because it does tend to get a little complicated. But next week when we do length of a sector and area of a sector, we'll use this a lot more. But I'm going to start it today because it gets a little complicated. But we will go through your homework more. You probably won't use this equation a lot, but I do want you to see why we need central angles to do it and to start introducing it. Right here, this little thing that says through, this little thing right here that looks like a O with a line through it is called a theta. That stands for our central angle. S stands for our arc length. And the C stands for our circumference. And what's really nice about this equation is it's just cross multiplying. It's very simple.
How did they get S from R?
Its sector length is the same as what they can use it from. Okay? So example 1. In a circle with a circumference of 72, find the measure of the central angle that is interpreted by an arc with a length of 12 inches. So we know 3 out of our 4 things. We do not know our central angle. We do know 360. That's just the angle of a circle, right? Equals the length of our arc, which is 12, over our circumference, which is 72. And then it's simple cross multiplying, right? 72 theta equals, and you can use x instead of theta if that works for you, 12 times 360, which gives us 4,320. Okay, now I'm going to divide 72. I know my handwriting isn't great, so I rather use x because I think that means 720 a lot of times, and it doesn't. It means theta. So my central angle is 60 degrees. You divide by 72 to get theta all by itself. Okay. Example 2. How large an arc is interpreted by a central angle of 6.23 and a circle with a radius of 10? Okay. How large is an arc? It has a central angle of 6.23, so I put that in for theta, over 360. I'm looking for my arc length, S, over, well, I don't know what the circumference is, but I do know the radius, so I'm going to say 2 pi 10. And I'll just do it all together. So I get 360S, and I'm going to go 6.23 times 2 pi 10. And I get 391.4 approximately. And then I'm going to divide that by 360. And I get S equals 1.1 approximately. And that's centimeters. Okay, example 3. In a circle, the central angle is 40 degrees. So you've got half of it already. The interpreted arc measures 55. I want to know what my radius of my circle is. Okay, so I'm looking for arc. So first I'm going to go 360 times 55. I get 19,800 equals 40 times 2 times pi times r gives me 251.3 approximately r. 19,800 equals 251.3 r. Then I'm going to do 19,800 divided by 251.3, and I get r is approximately 78.8. Okay. We're not going to do the last one because I haven't told you how to do parts like that. Just those 3. Okay, now I'm going to do problems from your homework so that you can use them as examples. The first one we're going to look at is number 6. Okay. Major arc for number 1. Major arc means it's greater than 180. So I have to do, instead of AB, because that's not bigger than 180, I do the other side. Okay? So that angle would be, the major arc would be ACB arc. Okay? If I was doing the minor arc for number 1, it would just be AB arc. Okay?
That's
All right,
the answer?
that's it. That's what I have to do. All right, let's look at number 10. If my central angle is 123, what is my arc? What did I tell you in the circle book notes? There. Central arcs are what to their, central angles are what to their arcs? Equal. So it's 123. That's it. Okay, let's turn it over and look at the ones in the back. The back's where it gets harder.
Oh no.
All right, let's just do number 16. Okay. We have to find x. Do we agree that these little arcs down here inside my circle mean that they're equal to each other?
Yeah.
Yeah. So this is x plus 93 as well. Do we agree that this half right here, those two angles added together, makes 180 degrees?
Yeah.
Okay. So we're going to go x plus 93 plus x plus 93 equals 180. So we get 2x plus, I'm going to combine like terms. Sorry, I'm going really fast. I'm going to slow down.
Yeah. Thank you.
I added both of these together, set it equal to 180 because I know it's a semicircle. Now I'm combining like terms. X and x is 2x. 93 and 93 is 186 equals 180. I'm going to subtract 186 from both sides. And I am going to get 2x equals negative 6. I divide by 2. And I get x equals negative 3. A negative number is okay because it's not a length, because we have not plugged it into the equation yet. It wants to solve for x. Okay, if we were to put this in, that means both these angles are what? 90. And that's a positive number, so we're okay. All right? You have the rest of the hour to work on this. I don't care if you move seats. Before you do, though, I do want to talk about if you were absent on Friday, and have not gone on Khan Academy. Okay? You simply go to Khan Academy, Google it. You should sign up if you haven't already. Everybody should do this. It helps you study for the SAT and the PSAT. You just enter an email and you should get started. The only thing you need to do in order to get credit for it is, depending on which hour you have to sign me up as a coach so that I know you did it so I can give you points. So I've got first hour is TP3CRY. Second hour is H7Y7KQ. Third hour is 8RC5K6. Fourth hour is EKD6BZ. Fifth hour is QU6ZES. And sixth hour is 2BGDD4. Okay? You need to do this. Khan Academy should be something you guys, if you don't do anything else school related, besides, of course, some of you will get course packets to prepare for next year from your teachers, is you should be doing Khan Academy. I would do Khan Academy on a regular basis. I would do it twice a week over the summer for no more than half an hour each time, just so you stay up to date on it. And you are prepared. Most of you guys are in 10th grade right now and are going to take the SAT next year. And you want to make sure you know how to do all this stuff. Keep it fresh in your mind. Over the summer, I would do the PSAT prep. Okay? For me, to get credit when we do Khan Academy, you do need to do I would rather you do a geometry part. Okay? All right, guys. You have the rest of the hour to work on your homework. And